Okay, let's discuss this question, tutorial 3.1, part 1, question 3. So in this question, you are using a light source of 450 nanometer, and point Y and point Z are the first bright fringes from the central maximum. So this is your central maximum, and at Y and Z are the first bright dark fringes. So in A, right, state the difference in the distance in nanometer for each slit to point Y. Okay, the difference in the distance is referring to the path difference. In part A, what we want will be the path difference between the two light sources that comes out from S1 and S2 to point Y on the screen. And since Y describes destructive indifference, means the path difference must be equal to m plus half lambda. And we know that this is the first order dark fringe. So for the first order dark fringe, right, n will be equal to 0. So substituting for this, so half lambda is the same as half times 450 nanometer. So the path difference will be 2 to 5 nanometer. So this means that when the light source comes out from S1, it's traveling towards point Y on the screen. And when the light source comes out from S2, it's also traveling towards point Y on the screen. The path difference between them is 225 nanometer. Okay, for B, right, determine L. There is this distance between the double slit to the screen. Okay, for this, right, we use the formula, the fringe separation, that Ry is lambda L over D. So what we want to find will be L. So L is actually delta Y times D divided by lambda. Okay, delta Y is a fringe separation, that is the distance between adjacent maximum or the distance between adjacent minimum. So in this case, right, this is equal to 2 millimeter. So 2 millimeter is the distance between maximum and minimum. So in other words, right, the distance between two adjacent maximum will be 2 times this value. Okay, if you see that, it's destructive, destructive, destructive. So assuming this is your central maximum, right? This is point X. And this here is your point Y. Right? The first order dark fringe. So delta Y is between adjacent maximum, between maximum zero order and maximum first order. This is your delta Y. So since this is 2 millimeter, that means delta Y is actually 4 millimeter. So we know D is 0.41 millimeter, change everything to meters, divided by lambda. So lambda is 450 nanometer. So 450 nanometers is the same as 450 times 10 negative 9. So substituting into your calculator, we can get this will be 3.64 meters. So L, right, that is the distance between the double slit to the screen, is basically 3.64 meters. Okay, subsequently, C, quantify the change in the pattern seen if the 450 nanometer laser is replaced by a laser of 675 nanometer, keeping other factors constant. Okay, for C, right, we know that delta Y, the fringe separation, is proportional to lambda, which means the larger the lambda, the larger the fringe separation. So in this case, right, we have to quantify by how much will delta Y increase if I change the original light source 450 nanometer to 675 nanometer. So what we do is we divide. So this is my original fringe separation, and this is my new fringe separation. Let's call this delta y prime equals to the original lambda, which we know is 450 nanometer, divided by the new lambda prime. So what we want will be, what is delta y prime, the new fringe separation. So the new fringe separation is basically the new lambda divided by the original lambda times the original fringe separation. So this here will be 675 nanometer divided by 450 nanometer. Okay, nanometer, right? So there's no need for you to write this, right? Because they can be cancelled out. They are common factors, so they can be cancelled out. So times the fringe separation. So what's the original fringe separation? It's 4 millimeter. So changes to meters. So using a calculator, you can find that the new fringe separation will be 6 millimeters, or 6 times 10 to the power minus 3 meters.